So the whole idea here is a what if. We're going to try, what if light pollution as it is right now was always the case? What if, and alternate histories, they're big in science fiction. Everybody's been doing it. You just take one crucial part of history and you change it. So a lot of World War II, a lot of the South won the American Civil War, a lot of things that people choose are deciding critical points in history. But what I'm going for is, let's have that separation, that diversion happen about 500 years ago, before telescopes. Telescopes are about 400 years ago. And how would that change history? It would change so much. I'm mostly talking to science fiction authors here because that's mostly who's on the call. So I want you to be thinking of story ideas that might come out of this. So here's light pollution. Here's what it looks like from satellites above. And it's pretty shocking. I mean, look at Japan, the eastern part of the United States, Europe. You can't see North Korea. The mountain chains where all the observatories are run a lot of times up the western coast of South America. And even there's light pollution. It's getting worse. These light pollution maps are heat maps of where the light pollution is. And you can see it started when with megalopolis, that Washington, D.C., Baltimore, New York, Hartford, Boston run. And that part has just gotten worse. Oh, I missed Philadelphia. That part has just gotten worse. And east of the Mississippi, there's probably not too many dark spaces anymore. It's easy to find a light pollution map. You Google light pollution map, or you go to a site like this. And each year, the VIIRS satellite takes another map. So the 2021 is actually up since I made this slide. And the 2021 version will be up in a couple of months. And you can go anywhere on the world and look and close up. And I love doing this. I could just look at maps all day. I think it's just so much fun. Even if you have mountains or the curvature of the earth, you still get light from a bright source, even around a corner, basically, because the light is scattered by the atmosphere. And it's preferentially scattered by the atmosphere. So blue light is scattered more than red light. This is Las Vegas, and what happens in Las Vegas doesn't stay in Las Vegas. This is hundreds of miles away. So you're still getting what we call the dome over the city, or sky glow from Las Vegas. The Luxor beam is actually visible in this shot. I don't know if your screen can show it, what the resolution of your screen is, but that's the brightest spot on Earth from above. Blue light, because of its short wavelength, scatters around in the sky. That's why the sky is blue during the day, but at night, blue light scatters more than red light. And light emitting diodes, LEDs, are much bluer than the street lights and the other lights that we've had in the past, incandescent bulbs. So as history is proceeding, we're getting bluer and bluer and bluer, so more and more and more light is scattered at night. So you can see the city center here, they've already changed the lights to LEDs, whereas in the suburbs, they haven't done that yet. And the white, bright LEDs in the city center are a mistake, in my opinion, because they're too bright. But that's what lighting engineers had said was necessary. And you still have always this idea that bright white lights at night, making it look like day, is safer, and it makes you feel more comfortable that you are safe. Actually, studies haven't shown that at all. It's the perception of safety. We feel safer when we can see at night, but we are not actually safer. I mean, most crimes happen during the day. And if lighting up something was the key, then why did 7-Elevens and gas stations get robbed, right? So what we're trying to do is change people's perception. This is what I really want people to see. You can go out to the mountains in the west. You can go on a boat in the middle of the ocean. You can see a clear, dark sky like this. This Milky Way is the edge of our galaxy. So it's the whole way around. This happens to be looking towards Sagittarius, towards the center of the galaxy. But you can actually see this Milky Way in all parts, all around, like a cylinder. We're embedded in the middle of the Milky Way galaxy. So we see it everywhere from every location on Earth. And there's thousands of stars, 5,000 or 6,000 stars that you should be able to see from a dark site. The dark banding here is gas. So the Milky Way has 400 billion stars, and the dark banding is the gas and dust that is collapsing down to make more stars. This is how we tell what kind of a site you're in. So a really good site, an excellent dark site, is Bortle scale 1, and it goes 1, 2, 3, 4, 5 up to 9, and 9 is the inner city. So there are places on the planet, notably places like Beijing and Singapore and Bangkok, where my Carnegie Mellon students come from, but can't see any stars, like literally no stars, a few planets and the moon, and that's it. Part of it, especially in Beijing, is air pollution as well as light pollution. But even when you don't have air pollution, the sky itself is so bright, and there's so much light bouncing around, so much light directed upwards, that it obliterates the stars. This is the more detailed Bortle scale. And I just point this out to you because where I live in the city of Pittsburgh, I can actually see the Milky Way sometimes on a clear, dark night with no moon. I can see it overhead. It's washed out, but I can identify it and be like, look, right, 2 Cygnus, there's the Milky Way. And that's not really supposed to be a city sky. So my feeling is that those satellite maps, they're not really detailed enough to tell. And we need better, more high resolution maps of light pollution. So obviously astronomers need dark skies. It's one of our laboratories. It's the entire hemisphere above you, and anyone should really be able to see it. I'm not sure how children go into STEM fields without seeing stars and wondering what's out there. We have books that come out every year from NASA that's all the things that the space industry has discovered, made, found that are helpful here on Earth, including a few things like cell phones and CCD cameras. And we, through the use of developing telescope optics, we've really helped all kinds of industries. So you don't even think of it. I just had cataract surgery done, and astronomers' understanding of how optics work and how the eyes work was really helpful for that. Communication satellites. This is the Green Bank telescope. So this is large enough to put a football field in the center of. It's the largest fully steerable radio telescope on the planet. the bowl, and then the feed is way up on top. That's where all the radio waves from the cosmos bounce and converge to the point up at the top. This is in West Virginia. It's a little over 4 hours drive away from Pittsburgh. And this is where I take my students. Every year we get on a bus, except the last couple of years, the last year, we get on a bus and we fill it full of students, like 50 students, and we go down there for an overnight. And they can see a big, clear, dark sky. I had one astronomy student who grew up in Miami. He was the president of the astronomy club. And we were walking at night and you could just see everything. It was so beautiful because you're in a radio quiet zone. You're ringed by mountains and nobody wants to live there because you can't have cell phones or microwaves because it's a radio quiet zone. So it's very dark there. And he said it was like walking in a freakily large planetarium. He'd never been under a dark sky before. He was studying astronomy. It's just such a shame. But if you want to go, this is the way to go. I've heard that Cherry Springs is great, up Route 28, about 4 hours. And I haven't been yet, plan to go. But I mean, supercomputers were modified and designed specifically to do the large simulations that astronomers do. You take every single point in the universe, obviously not every single point, but you take enough points to get a good simulation, and you give them mass and you give them a velocity and a direction, and then you let the simulation run. And from that, we have realized that, like this first box here, kind of uniform mass over time, the second box, the third box pulls together because there are slight variations in the amount of mass in any one location. Gravity pulls it together. And so you get these flattened and filamentary-like structures with voids in between. And that's the large scale structure of the universe, which would not have happened if the initial state of the universe hadn't had some variation in mass in it. So we can learn so much by running these simulations, large cosmological simulations, all kinds of sensors and detectors, because astronomy is multimodal. You've got every part of the electromagnetic spectrum that we want to look at. Mostly we have to go above the atmosphere because the atmosphere cuts out gamma radiation and X-rays and ultraviolet radiation that is higher energy that you would not want to hit your skin, right? UV gives you skin cancer. So we send our telescopes up above the atmosphere to capture everything except for visible light and radio waves. And we've developed all kinds of scanners to understand how to capture all kinds of radiation, which then everyone else uses. We look down on the Earth from space and take all kinds of readings and understand temperatures of oceans, which can then come into play when you're talking about so many Category 5 hurricanes lately and climate disruption. We find that if you're not looking, you could have some sort of catastrophic event happen because of the asteroids and all kinds of large meteoroids that are floating around in our solar system that have not been swept up yet by mostly large bodies like Jupiter. But there are dangers out there. And if you couldn't see, if you had light pollution everywhere and you could not see, we would be literally in danger. So there's all this stuff. There's all this stuff that would have happened from GPS systems and cell phone cameras, the little CCDs in cell phones. So how is this not absolutely critical? And on everybody's list is to stop light pollution. So here's the thing. We would have never found Neptune. So let me tell you the story. Neptune is not an object that you can see with your eye. Uranus it's very, very, very faint, but you could see it as a steady looking light from a really dark site if you knew where to look. The difference between seeing a planet and seeing a star, stars twinkle and planets shine with steady light. Twinkle, twinkle, little star. What that means is that the light from a star, which is a point source, comes into the top of the atmosphere, and movements of air currents, clear air, but at different temperatures, move between the starlight coming in at the top of the atmosphere and you on the surface where you're looking up. So clear air could be large cells of warm air and large cells of cold air drifting in the air, and they're different densities. So when light from the star comes to the top of the atmosphere, it gets refracted through these different densities of air and moves this way, this way, this way, this way, so that you see the star as if it's over there, over there, over there, over there, moving around just a little bit, enough to make it look like it twinkles. Planets, being disks, they move around a little too, but they're still in the same location. That slight change isn't enough to change how a planet looks. It still looks like a disk. So what happened with the discovery of Neptune is outside the orbit of Uranus. Scientists had enough good data on Saturn and Jupiter and Uranus to realize that there were perturbations. There were little wiggles in the orbits of the planets due to the interactions with the other planets. Saturn changed the way Jupiter moved a little bit. Jupiter changed the way Saturn, Uranus moved a little bit. But when we looked at Uranus's orbit, there were perturbations there. Couple people really did it at the same time. Urbain Le Verrier was a mathematician, a French mathematician, and he calculated where he thought there might be another outer planet from these perturbations in the orbit of Uranus. John Couch Adams in England did the same thing. And he tried to get the Cambridge Observatory to look, but his calculations weren't actually great. History reports that he was young and people ignored him. That's not actually true. The truth is his calculations were really very good. But Leverrier's calculations were excellent. And he tried to get the French observatory nearby to look at it, and they declined. And then he sent the location to the Berlin Observatory. And within an hour of looking, after midnight on this one particular night in 1986, they found a planet. They didn't call it Neptune yet, but they found a new planet. It's the only one that has ever been discovered because someone said, here's where you should look. There's probably a planet there.
Did you say 1986?
Sorry, 1846. So,
oh, thank you.
Yeah.
You were just making sure we were still awake. I know.
Good catch. So it's something that was a monumental achievement for science and for Newton's laws and the understanding of how elliptical orbits, the planets ran in elliptical orbit. And it would not have happened because here's a picture of light pollution as it is right now in Europe. It's really covering the whole of the area. And here is Berlin I've marked the observatories. Here's the one they use, the oldest one. And there is zero chance they would have found a planet at this rate of light pollution. So I'm just picking some examples. I thought about this because lately I've been listening to some folk songs. And here's one. It's called Follow the Drinking Gourd. And it's one that is a really old American folk song that was a a hidden code in it for slaves that wanted to try to go north to escape to freedom along the Underground Railroad. The words are pretty clear. It's like a map. You go up the river and there's some hills and you follow the drinking gourd, which is the Big Dipper. So the Big Dipper is this gourd shape, right? We don't drink out of wells anymore. We don't have dippers anymore, but back then they knew what that meant. The two stars in the bottom in this picture of the bowl of the Dipper point to the North Star, which is Polaris. It's the star that is almost exactly at the North Pole axis of the Earth, above the North Pole axis of the Earth, the North Celestial Pole. So 5 times the distance between those two end stars in the Big Dipper's bowl, 5 times the distance between them leads you to Polaris, which is not the brightest star in the sky, as a lot of people think. It's the 50th brightest star in the sky. So you really need something to point you there, point you north. And would they have seen that? So I'm not really sure, but I think they probably still would have, because we're talking about light pollution as it is now, back in time. And they were going at night, avoiding all the population centers up. And, here's the Mississippi River. So they were probably traveling up this direction, up to Chicago-ish area. And I suspect they would have been okay. So if you're writing an alternate history, that might not be the way to go. But this one is an interesting one. So Olber's paradox. This was mentioned by Kepler back in early 1600s. The idea is that if the universe is static, it is what it always is and always has been, which a lot of people wanted to believe. If it contains an infinite amount of stars, and if it's the same in all directions, and we're not at any special point in it, we should actually see every part of the night sky being as bright as the sun. Think about it. Every direction you look, you should hit the surface of a star. The sun is a very average star, so that's a good average to take. Every direction, you should see the surface of a star. Everywhere you look, there are hundreds of billions of galaxies with hundreds of billions of stars in each one. In every direction you look, you should always see that same brightness. And people discussed it all through the years. Edgar Allan Poe had a really good understanding of this and had a lot of dialogue with other people about it. And it puzzled everybody because they wanted to believe the universe was static. They wanted to believe that it was the same everywhere. And it wasn't until 2 things. First off, the Big Bang theory says that the universe began at a certain time, 13.8 billion years ago, back in time. The universe had a start. It had a beginning expansion. So that would change Olber's paradox. So we wouldn't have a problem. But then we came to understand that because of that, the universe was denser in the very beginning and then expanded. So it was hotter in the very beginning. And that increase in temperature would cause this to be a problem. We would see a hotter temperature everywhere. But then comes the point that the universe is expanding. And what that means is that all the wavelengths of light are expanding. So what happens when you have a short wavelength, like blue light, and you expand it because light is traveling through the universe? If the universe is getting bigger, the wavelength of light is getting bigger. What happens is it changes from blue light to red light. If you stretch those wavelengths, and you keep stretching them, and the universe is billions of years old, you keep stretching them, it becomes, at this point in time, microwave light. It's in the radio region of the spectrum. And so the sky is dark for our eyes, which see only in the visible wavelengths. So Obler's paradox was discussed, philosophers, mathematicians, astronomers, everyone was discussing this up until the point where we realized that the universe had a beginning and the universe is expanding. So now we understand why nights are dark. There were hundreds of years in there where people were like, we don't understand why we see a dark night sky. So with light pollution, they would have never had any of that discussion. None of that would have taken place. We probably still wouldn't know that we live in an infinite expanding universe with a finite start. So I'll tell you about this book, this Triangulation Dark Skies book. The idea was we were going to do light pollution stories. Well, light pollution has actually gotten a lot of press since we put this book out. And this was paid for by the Metro 21 grant that I got from CMU. Stories about light pollution are rare in the world. So a lot of the stories in this book are stories about stars and seeing stars. But there's one in particular that I wanted to mention, and that's Why We Endured the Darkness by Maddie Dietz. It's a story where there's so much light pollution that no one has seen stars for many, many generations. There are still stories about it, but no one has seen them for the longest time. And only the organized religions have rockets that take people, true believers who pay, up above into space so that they can see the stars. And the story is about one couple who makes their own rocket to go up above all the light pollution so they can see if it's true or not, that there really are stars and they're not controlled by religion. So Maddie is amazing. She was at Confluence last year. She was doing a lot of the interviews for authors. She won the she was named the 2020 National Student Poet, one of 5 students in the country. And she's had quite a career already as an early Princeton University student. The way that I met her is the way I meet all the young people who are really good at writing is through Alpha, which is part of Parsec. Alpha, the science fiction, fantasy, and horror writing workshop for young writers. So light pollution affects more than just science of astronomy. That's what I talk about because that's what I'm interested in. But it does affect plants and animals. Every single thing that we've studied, there is a definite effect on all sorts of patterns. Algae are affected, fish are affected because they have to go to different levels to get the algae, which don't grow anymore at the levels where the fish is used to. Coral is affected. Bleaching of coral happens. And some coral reefs are hundreds of years old. They take a really long time to regenerate after they're destroyed. So plants, trees, if tree is near a street light, it is measuring the seasons and the days that pass by looking at light levels. As everything on our planet is millions of years, we evolved here to take into account that summer days are longer and winter days are shorter. And so the trees leaf out too early in the spring near a light source, and they hold their leaves too late in the fall near a light source, so that they invite insects, and they can be harmed by that. Obviously, things like owls that rely on their excellent night vision to forage for food, but it's anything that is hiding from a predator or is trying to find prey. And bird migration is a big one. There was New York City yesterday, there was an article where thousands of birds were found dead at the bottoms of lit up buildings, and everybody's up in arms today about that. Well, we knew that. About 600 million birds every year die from collisions with buildings and getting disoriented and going off their migratory paths. And this is the beginning of migration season. So there's places like Lights Out Philly and Bird Safe Pittsburgh that are encouraging buildings to turn off their outside lights so that doesn't happen. Fireflies, obviously, they mate by making lights. And so if it's too light and they can't see each other, some populations are down by 90%. It's really hard. So what is Pittsburgh doing about it? This is what hit this week. And I got to be on NPR's Morning Edition. It says 13 million people that listen to it. 13 million. I've never talked to that many people before in my life. So Pittsburgh decided that we're going to have dark sky ordinances. All Pittsburgh properties, playgrounds, facilities, the parks, everything that's on Pittsburgh property, that means the zoo and PPG Aquarium, the National Aviary, Phipps Conservatory, all of those had to agree that they were going to go dark sky compliant, along with all the streetlights that are about to be changed from high pressure sodium vapor to LEDs. So you can read the new dark sky ordinances. If you have any trouble sleeping at night, I highly recommend them. They go on and on and on. But the basis is that we just want to lower the temperature of lights because then it affects everything less, plants and animals and people. The lower temperature you go, the less of an effect we've found. So the street lights that are LEDs already that Pittsburgh has, they have about 5,000 of them. They're at 5,000 degrees Kelvin. The ones we want to put in are around 2,700. It's not my decision. I will find out, but I can't make any promises at this point. That's the office, the DOMI, the Department of Mobility and Infrastructure under the mayor's office, that is making that decision. They put out the request for proposal in summer. They got all the lighting manufacturers to give them ideas of what they would like to put up and how much it will cost. And the decisions are making now. Contract phase starts in a little bit. They're going to start being put in by the end of the year. But I just wanted people to understand that when we talk about 4,000 Kelvin, 5,000 Kelvin lights, we're not talking about lights that are that hot. They're not that hot. That would be like the surface of the sun hot. The surface of the sun is like 5,800 degrees Kelvin. We're talking about a temperature that's a value that's like what that little thin wire in an incandescent bulb gets to the temperature of. Like a teeny tiny little wire might get to a few thousand degrees Kelvin. It doesn't, since there's such a small amount of it, it doesn't make the entire room that hot, right? Incandescent bulbs are now outlawed in many countries because they're totally inefficient. They're just not good at all. 90% of the energy you put into an incandescent light bulb comes out as heat. She's great if it's cold and you're in the winter, but LEDs are the way to go. They can be made at temperatures that mimic low temperature incandescent bulbs. Anyway, these are the guidelines that the city has picked. Just light what you need, just as bright as you need. Shield them so the light doesn't go up into the sky, because that's just lighting the undersides of birds and airplanes. You really don't need that. Just light when you need it. So timers, dimmers, motion sensors. And if you choose bulbs that are called warm white, that means they're actually cooler temperatures. But that's what the lighting architects have named them, warm white bulbs. And that can make a huge difference. So will it really be a change? Yeah, we'll go from these lights that are unshielded and amber colored, which are the old ones, to something like the ones on the left of the screen. These are shielded. You don't see the glary bulb, which is bad for pedestrians. It's bad for motorists, but ours won't be that color. That color is too blue-white. That color scatters everywhere. That color is harsh, and it bounces around in your eye also, causing glare, especially with older people. Older people, people's eyes do adapt to the dark. If you're left in lower lighting conditions, your eyes will adjust. The irises will open. You'll get more light in. You'll be able to see better. But when you look directly into a bulb like this gas station, then your eyes shut back down and then you're blinded. And older people's eyes don't change as fast back and forth from lit up to dark conditions. So what I've been doing is driving around the city and getting my students to drive around the city and actually making a light pollution map using a mobile app on my phone. It's called Dark Sky Meter. It's like $2. And I just take my dog in the car and drive around and stick my arm out the window and take a reading every once in a while. And it's really different all over. And so I'm trying to get my students to make a heat map, maybe a 3D heat map of the city and where it's dark and where it's bright. You got a point here in Bakery Square and one at the Science Center that I didn't take, these red spots. But you have to go when the moon isn't out and when there's no snow on the ground because that bounces light everywhere. One of my students made lines outside a whole bunch of cities where you could see the Milky Way if you go outside that line. And it's not a circle. I thought it would be more like a ring, but it's not. But the goal of Pittsburgh's new dark sky ordinance is to shrink that ring. You have to go about 40 minutes outside the city now. And if we start changing out these lights and everybody gets on board with it, that ring will shrink. And maybe you'll only have to go outside 20 minutes outside the city. So that's the goal. I love doing this because I'm totally non-confrontational, which people who know me, Kevin actually called it my avoid dance, and just dance around. I just like, okay, I'm out of here. I can't deal. So, but there's no pushback. Nobody ever says, well, no, I like my light pollution. No. So I like doing this. And it's starting to come out, and medical people are so cautious, but it's starting to come out that this really affects your health, people's health. Low levels, like 5 lux, maybe less of light at night, like a very small light, a night light in your room, can disrupt your melatonin production, which disrupts your sleep, so it causes insomnia, but it also can be tied to other things. All these studies are being done now, but they have to be done over long periods of time with hundreds of thousands of people before the medical industry will say, this is dangerous. There's a study in Boston with nurses that goes for 22 years. There's another study in LA with teachers, which is similarly with over 100,000 teachers. And they're tracking them and then checking for incidence of cancer. And there are other studies done with heart disease and diabetes. And it's coming out now that especially teens are more susceptible to depression when you have lights at night. So sleep in the dark, everybody. Please sleep in the dark. And I just want to say, this is my Mavic Pro drones. I got a bunch of these because, thank you, Grant. Thank you for the Metro 21 grant. And we flew these around, and What fantastic pictures. This is just the CMU campus. And I like that we got the stadium lit up because then you can see the resolution. I can close up on that and know that I've got like 1/3 of a meter resolution. But you can see the difference in the lights. I mean, these lights are way too bright along here. These lights we actually changed out. We got the city to put some 2700 and 3000 Kelvin lights because we're testing them. That's Margaret Morrison Boulevard. This is the Hunt Library. What an eyesore that is. The tennis courts. And this is Phipps Conservatory, which is beautiful. I have to admit it's beautiful. I mean, light always meant progress and celebration and joy, right? It makes you happy to see something like this. And I don't know how they're going to shield their lights from going up into space because it's a greenhouse. You need to have glass roofs. So that's going to be interesting to track that and follow that. We went, this is Southside. So we went from the jail, which we got kicked out of the jail airspace. They were really mad at us. We were like, can't do that, I guess. We went across the river, which was completely black, and then up here and up Mount Washington and over the other side. And it's interesting to see all the different places, but a drone was too small. We couldn't do it. So we got a Cessna. We slung a camera. It was a Sony Cyber shot on an anti-vibration mount under the Cessna, which went in a lawnmower pattern back and forth over the city. But it was not GPS controlled. And even though we got great shots, nice little sharp dots, right? And they're not streaks. This was the second trip. The first one, everything was a little streaky. So we told them to fly lower and slower. But this was our lawnmower pattern, which, yeah, if your landscaper did that to your lawn, I don't think you would pay him or her. So this really wasn't quite the way to go yet. We can close up on all of these and it's beautiful shots, but yeah, that's not what we're trying to do. We really want to get a helicopter. So that's our next goal. But we have now astronauts taking photos from the ISS, and they're not high resolution, but they are absolutely wonderful. They're going to take them of Pittsburgh before, during, and after all the streetlights get changed, which takes maybe 2 years. And thank you for that. And I know you might have questions, so I'm gonna stop share.